In part 1, our goal was to find where x was on the number line. So we had something like x is greater than or equal to 3. And then we plotted that on our number line. So again, we don't know what x is, but it's greater than 3 or equal to 3. So we'd mark that on our graph, on our number line, like this, just showing that x is somewhere in that area. And I mentioned that we can think of this as an x-axis. When we looked at linear equations, we had an x and y-axis, x-axis here, and y-axis here. And then we would draw a line. Well, if we can think about our x-axis, as we've done, can't we think about the y-axis as well? So what if I told you something about y? What if I told you that I don't know what y is, but it's less than -1? Well, let's draw that on the y-axis. So I have the y-axis, it's vertical, right? Because our y-axis is vertical in our xy chart. And so we want to find where y is on this y-axis. So it's less than -1. So we put a circle around -1 and we go down because it's somewhere in this area. It's less than -1. So now that we've thought about this as an x-axis and a y-axis, well, I think you know what we're going to do next. We're going to combine these ideas. So let me give you a problem. Show on the xy chart where x is greater than or equal to 3. Okay, so we're going to have an xy chart, and it's essentially going to combine these two. We had an x-axis and a y-axis, so now we're going to combine the two. So how about I just combine them? And when you combine an x-axis and a y-axis, you get our xy chart. Right, let me get rid of that 0 for a second. Okay, and they fit right on top of each other, and we get our xy chart. When we had just our x-axis, this is what we had. We had just our line going on our x-axis. Well, let's think about it. How does our y-axis change things up? Consider this point right here. What is this point? What's the coordinate for that? Well, that would be x equals 3 and y equals 1. Well, x equals 3 right there. So that's where x is greater than or equal to 3. So we should consider that as part of where x is. We're part of our solution. Well, what about this point up here? Well, what's the coordinate? That is x equals 3 and y equals 3. Well, that should be part of our solution too, because x equals 3 there. Well, if you think about the entire line, up and down, this entire line is where x equals 3. And the same way, this entire line is where x equals 4. Originally, we just had our x-axis here, but with the y, when we're including the y's, we're kind of expanding how many points are in our solution. So you can keep actually drawing lines up and down, and what you get for every x that's greater than or equal to 3 is not just an arrow on the line, but you get an entire region here. This entire region is where x is greater than or equal to 3. Because it follows this idea of where x is on the x-axis, and then it expands it up and down to include all the possible y's. So any point in the blue region, x is going to be greater than or equal to 3, and y is going to be some other value. So it doesn't matter what y is, but that is where x is greater than or equal to 3. Okay, well, let's think about the other side, where we had y. So what if I want to add something to the question? I want to show where x is greater than or equal to 3 and where y is less than -1. Okay, well, we thought about it originally with this y-axis here. We just thought about it as one axis. However, pick a point. Pick a point right here. Oh, what is that point? What is the coordinate for that point? Well, that would be x equals -2, y equals -2. Well, isn't that point, doesn't that satisfy our y is less than -1? It does. So taking this idea, just as we did with the x's, you can think of any point on this line as somewhere where y equals -2, and you can draw the line. That is where y equals -2, and you could do that again with y equals -3. So all of these, anywhere, any point on these lines is where y is less than -1. But now we're considering the x's, so we kind of expand it left and right. And so overall, we can say that this entire region below our circle is where y is less than -1. And with our circle, we don't draw a line left to right, we draw a dotted line because this area is where y is equal to 1, but we want to emphasize that we're not including this as part of our solution. So everywhere below the dotted line is where y is less than -1. And when we had our green lines, we had it as a shaded line. You can think of it just like we shaded the dot and then kept the open circle. When you have something equal, you shade the line. When you have it less than, you have a dotted line. So our pink region is where y is less than -1. Let me shade that just a little more up to the line. Our blue region is where x is greater than or equal to 3, and this overlap is where both are true, is where x is greater than or equal to 3 and y is less than -1. That overlap region right here, where you see the colors overlapping, that is where both of them are true. Okay, let's try one more, now that we kind of have an idea. Show on the XY chart where y is greater than or equal to 2x minus 5. Okay. Again, we'll draw our x-axis and our y-axis, x, y, and these are two number lines that we're now kind of combining. And when you see this y is greater than or equal to 2x minus 5, doesn't it kind of look like our linear equation? Y equals 2x minus 5, y equals mx plus b? It does. So that's where we're going to start. So let's go ahead and graph that. Our y-intercept, -5. Let's go ahead and put that on here. So that is going to be a point on our line. and our slope is 2. So every time x increases by 1, y goes up by 2. Or you can think of it as rise over run, 2 over 1, rise 2, run 1. Either way, you get to that second point. And so let's go ahead and draw the line. Okay, so we have our line. This is y equals 2x minus 5. We want to take a look at y is greater than or equal to 2x minus 5. So what happens when the equal sign becomes greater than or equal? So let's consider some points. Consider x equals 1. Okay, so we plug that in to our inequality. So we get y is greater than or equal to 2 times 1 minus 5. And that is equal to 2 minus 5, which is equal to negative 3. Okay, let's try one more point. X equals 2. Okay, so we plug that in, we get y is greater than or equal to 2 times 2 minus 5. And that's equal to 4 minus 5, which is equal to negative 1. Okay, let's list our observations here. When x equals 1, y is greater than or equal to negative 3. When x equals 2, y is greater than or equal to negative 1. Okay, let's try to visualize that. So x equals 1 and x equals 2. So when x equals 1, y is greater than or equal to negative 3. So if we just had an equal sign, it would say y is equal to negative 3. Okay, so we'd say y is equal to negative 3. But it's saying when x equals 1, y is greater than or equal to negative 3. We don't know exactly what y is, but we just know that it's in an area. So y could be negative 2, right? Or it could be 10 up here. It could be another number. It could be anything greater than negative 3. So it's essentially anything up on this line above negative 3. Well, same idea for x equals 2. When x equals 2, y is greater than or equal to negative 1. If it just said equals, we would say y equals negative 1. So we'd think about just that point. But now with an inequality, we're saying y is anything greater than or equal to negative 1. So it can be any point greater than or equal to negative 1. So in the same idea, y can be any point on this little pink line going up. And so if you keep on doing that for every x, what you notice is that our area where y is greater than or equal to 2x minus 5 is going to be the entire area up here, the entire region above this line. Because every point, every sample for x that you pick, you're just going to keep getting lines that go up and up and up and up and up. And so eventually you're just going to get this entire pink region above the line. And it includes the line because there's that equal sign right there. So it's basically taking our equation for the line and expanding it, saying it can be greater than anything on the line, meaning above the line. Okay, so what if I added an extra step to this? And I said, I want to know where y is greater than or equal to 2x minus 5 and where y is less than negative 1. All right, I gave you an easy one. We just did. Y is less than negative 1. That's where this pink region is. So let's go ahead and plot that. So y is less than negative 1 is going to be everywhere below this line. Everywhere below the line. This area right here, that is where they overlap. That is where both of them are true. So the overlap is where y is greater than or equal to 2x minus 5 and y is less than -1, where both of them are true. So as you do these problems, you are going to notice that anytime there's a greater than sign, that's going to mean to shade above the line. Because we're taking that y equals mx plus b, that idea of a line, and we're just saying we want y that's greater than that as well, meaning above the line. And when you see this less than sign, that's going to mean shade below the line. Why? Well, what if this was y equals -1? That's going to be this green line, but it would just be a solid green line. But we're saying y is less than that. So we're saying we're going to give it a dotted line because we don't want y to be equal to 1. And everything below that is going to be also where y is less than -1. So think about how we started with just the x-axis and the y-axis. And when we combined them, we're kind of expanding them. With the first example, we expanded it up and down with our blue region, just to incorporate all the possible y's. Because everywhere up and down, x is still equal to 3 or greater than 3, but we just have some different y's going on. And same with the pink region. We started with just our number line and we went left and right because that's just where different x's are. So with inequalities, when we combine them, we end up getting regions. And go ahead and think about this idea of shading above and below the line. It's a great tip instead of having to pick points every single time, and it'll help you get through homework just a little bit quicker.